Hello everyone, in this video we are going to learn about gradients, tangent and normals to curves. Firstly, let's quickly recap the equation of a straight line with a gradient m that passes through the point x1, y1 is y minus y1 equals to m times x minus x1. For this lesson, we aim to use the derivative to find the equation of the tangent and the norm to a curve at a given point. Now we have the curve y equals to fx passes through the point A with the coordinates a, fa. So we have the gradient of the tangent at A is f dash A. In the graph, we can see the blue line is a tangent to the curve at point A. We know the equation of the straight line with the gradient m passes through the point x1, y1 is y minus y1 equals to m times x minus x1. So in here, for the tangent, similarly we have y minus, in here y1 equals to fa equals to m, we have f dash a times x minus a. So we just need to substitute them. Yeah. So we have the equation of the tangent at a given point. Well, recall that the product of the gradient of the tangent and the gradient of the normal equals to -1. If you know the gradient of the tangent at point A, we also know the gradient of the normal at the point A. So we have the gradient of the normal at point A is -1 over f dash a. So this is a normal at point A. The equation of that is y minus fa equals to -1 over f dash a times x minus a. Now we know the equation of tangent at a given point and also the equation of the normal at a given point to the curve. Let's see how to solve the questions. So for question 1, it said that for fx equals to x cubed minus 2x squared plus 3x minus 1, to find the equation of the tangent to the curve fx at the point 2, 5. So let's see. If we want to find the equation of the tangent to the curve at a given point, the first thing we need to do is to find the derivative of fx. In here, we know fx equals to x cubed minus 2x squared plus 3x minus 1, so that we have the derivative of fx equals to 3x squared minus 4x plus 3. Now we need to find the gradient of the tangent at the point 2, 5. The gradient of the tangent which also means that you need to find the derivative of fx at x equals 2 for this question. Now let us write down when x equals to 2, f dash 2 equals to 3 times 2 squared minus 4 times 2 plus 3. That equals to 7. So we get the gradient of the tangent. Then we can write down the equation of the tangent at this point. We know that the equation in general, that is y minus fa equals to f dash a times x minus a. So we substitute values into this equation. We have y minus 5 equals to 7 times x minus 2. And we rearrange that. We have y equals to 7x minus 14 plus 5. So the equation of the tangent at point 25 is y equals to 7x minus 9. So we have done the part A question. Now, part B said that you need to find the equation of the normal to the curve fx at the point -1, -7. So similarly, we need to find the derivative of fx at first. So the derivative of fx, that is what we have found in the part A question. So we can write down f dash x equals to 3x cubed, 3x squared minus 4x plus 3. And for the second step is that you need to find the gradient of the tangent. So the gradient of the tangent at the point. So for this one, we have another point that is -1, -7. Which means that you need to find the derivative of fx when x equals to -1. So we write down when x equals to -1, then f dash -1 equals to 3 times -1 to the power of 2 minus 4 times -1 plus 3. That equals to 10. In this case, we can find the gradient of the normal at the point -1, -7. That is -1 over f dash 1 equals to -1 over 10. So that we can get the equation of the normal at the point -1, -7. In general, we have y minus f a equals to -1 over f dash a, x minus a. Then we substitute value, we have y plus 7 equals to negative 1 over 10 times x plus 1. And we rearrange that, we will have 10y plus 70 equals to negative x, negative 1. So we have the equation of the normal at point negative 1, negative 7, that is 10y plus x plus 70y equals to 0. So we done this question. Now let me change the color that you can see obviously. Change another one, I think. Yeah, the purple one. So we done the first question. Now let's move on to see the second question. The question said that the point P with x coordinates 1 over 4 lays on the curve with equation y equals to 4x squared. The normal to the curve at P intersects the curve at points P and Q. Find the coordinates of Q. Well, firstly, we can sketch the curve and then to see what happened. So y coordinate x-axis and origin, we have the equation y equals to 4x squared. So we draw that probably is like that. So we have y equals to 4x squared with x coordinates. So we have the point P with x coordinates 1 over 4. So let us see, here is a point P. That is 1 over 4. It said that the normal to the curve at point P intersects the curve at points P and Q. Yet, as we want to draw the normal to the curve at point P, firstly, we can sketch the tangent at point P. So probably looks like that. Not so accurate, just to say that this is a tangent to the curve at point P. Now we know that the normal to the curve at P perpendicular to the tangent to the curve at point P. So we draw the perpendicular line at point P. So here is a normal to the curve at point P. We can see there is another intersection point. So this point is point Q. It said that you need to find the coordinates of point Q. In this case, we need to find the equation of the normal at point P, then we can find the point of intersection. If we know the equation of the normal at point P, then we can make the simultaneous equations to find the point of intersections. Yeah. So let's start. Firstly, we need to find the derivative of the curve. Let me change another color. We have the curve y equals to 4x squared. So the derivative of that is dy over dx. Let me change dy over dx equals to 8x. Secondly, we need to find the gradient of the tangent at point P. The gradient of the tangent to the curve at point P, which means you need to find the derivative of y equals to 4x squared at x equals to 1 over 4. That is the x coordinates of P. Thus we have when x equals to 1 over 4, dy over dx equals to 8 times 1 over 4, that equals to 2. So that we can find the gradient of the normal at point P. So we have negative 1 over dy over dx. That equals to negative half. Then we can write down the equation of the normal at point P. The curve at point P. In general, we have the equation y minus fa equals to negative 1 over f dash a times x minus a. In here, fa, that is when x equals to 1 over 4, y equals to 4 times 1 over 4 to the power of 2 equals to 1 over 4. So we can substitute the values into the equation. We have y minus 1 over 4 equals to, so the derivative, that should be negative half times x minus 1 over 4. And we rearrange that, we have y equals to negative half x plus 3 over 8. So that we can write down the simultaneous equations to find the points of intersection. Simultaneous equations that we have are y equals to 4x squared, y equals to negative half x plus 3 over 2. As you can see, the point Q both lay on the curve and the normal to the curve at point P. So we use these two equations to get the simultaneous equations. If you substitute the first equation into the second equation, you will have 4x squared equals to negative half x plus 3 over 8. We rearrange that by multiplying 8 on the both hand side. we have 32x squared equals to negative 4x plus 3. So we have 32x squared plus 4x minus 3 equals to 0. You can see that we can factorize the right-hand side. That should be 4x minus 1 times 8x plus 3 equals to 0. So we have two solutions. Firstly, let us write down if 4x minus 1 equals to 0, x equals to 1 over 4. Well, the question said that you need to find the coordinates of Q. Well, if x equals to 1 over 4, that is the x coordinate of the point P. So we don't use this value of the x. Yet we have another solution that is 8x plus 3 equals to 0. So x equals to negative 3 over 8. That is the x coordinate of the point Q. So let us write down when x equals to negative 3 over 8, y equals to 4 times negative 3 over 8 squared equals to 9 over 16. So the point Q have the coordinates that are negative 3 over 8 and 9 over 16. So we done this question. Yeah, for this lesson, we will learn how to find the derivative of the tangent and the normal to the curve at a given point, and thus we can find the tangent, and we can find the equation of the tangent and the normal to the curve at a given point. So here is the end of the video. Thank you for watching.